morning. I'm Srinivas Gowda, working assistant professor in IARE College. In this session, we will discuss about the various DBMS in interview questions we will ask in the technical round of the interview. We'll discuss. There will be 3 to 4 sets are there. Today in this session, we'll discuss the first set, that is. Okay, they'll ask you what is the database. So we know that database is a collection of data. Stored. It is a collection of data stored and retrieved digitally from a remote or a local computer system. So databases can be vast and complex, and such databases are developed by using fixed design and modeling approaches. So database is a collection of data stored and retrieved digitally from a remote or a local machine. That is what you have to say. What is data? Database will include tables and other objects. Other objects could be views, procedures, functions, triggers, indexes, and all things are a part of a database. So that is a database. Now, next question we will start up. What is a DBMS? DBMS stands for Database Management System. DBMS is Database Management System. DBMS is a system software responsible for the creation of the database, retrieval of the database, updation of the database, and the management of the database. So using DBMS, you can create, you can retrieve, you can update, and also manage the database. It ensures that our data is consistent, organized, and easily accessible by serving as an interface between the database and end users of the application softwares. So DBMS is a software used for creation, retrieval, updation, and management systems. Now they'll ask you what is RDBMS and how it is different. So RDBMS refers to the Relational Database Management System. The key difference here can be compared to DBMS is that DBMS stores data in the form of collection of tables and relations can be defined between the common fields of the tables. So most modern database systems like MySQL, SQL Server, Oracle, IBM DB2, and Amazon Redshift are all based on the RDBMS. So DBMS and RDBMS key difference is that RDBMS stores data in the forms of collection of tables and relations, which is not available in DBMS. Okay. DBMS. Now, what is SQL? SQL is a structured query language. It is the standard language for relational database system. It is used for handling, organizing the data compromised of entities and relations between different entities of the data. So SQL is a query language. And again, in that SQL language, we have many types. We have 4 types like DML, we have DDL, we have TCL, we have DCL, and DQ, data query language. So this is a language, it is a uniform language used to talk to database systems. Okay. Now, what is the next question is, what is the difference between SQL and MySQL? SQL is a standard language for retrieving and manipulating the structured databases. On the contrary, SQL is the only standard language used for retrieving and manipulating the structured language. On the contrary, MySQL is a relational database system like SQL Server, Oracle, or DBMS that is used to manage the SQL databases. Okay, and also in MySQL, SQL MySQL, again internally it uses TSQL for programming, and here it uses MySQL for programming language. So that is the what are tables and fields. Okay, next question, what are tables and fields? A table is an organized collection of data stored in the form of rows and columns. Columns can be categorized as vertical rows and rows as horizontal. So columns can be categorized as vertical and rows as horizontal. The columns in a table are called columns and tables are all fields. The rows can be referred as the records. So a table will have column and rows, column and rows. Rows will be horizontal. Rows will be vertical. Rows will be vertical. So a table, for example, table student having two columns, student roll number and name. So these are the two columns, and there are about two records, four records. Yeah, roll number 1, 2, 3, 4. Name is A, B, C. Now this is a table. And here row and roll and the name is the fields, and these are the number of records. Okay. Now we'll see on next question. What are the constraints in SQL? The constraints in SQL are some rules. Constraints are used to specify the rules concerning data in a table. It can be applied for a single or multiple fields in SQL table using creation of a table or after creation using the altered table. Okay. Constraints are some rules enforced on a table. They can be applied on single or multiple fields, and also they can be also created while the table creating, or can also be created after table is created by using alter command. So the various commands, various constraints we have is not, no, that means it will not allow you to choose insert a null value. Then we have a check condition. That means when you enforce a check condition, that means that you want to say my age should be more than 25 years, less than 25 years. Suppose you want to have a column value less than 25 years, you cannot use a check conditions. You cannot insert a value greater than that. Next, we have a default. Default means automatically assign a value. Suppose, for example, you want to assign a default date to your incoming student. So you don't need to write every day current date. System will generate a default date, that is current date. Next is unique key. So unique key will make sure that no two rows will have duplicate values. Okay, suppose I made my student roll number as unique. I cannot insert two same student records into the unique value. Next, I am going for index. Index is used faster retrieval of record. Your table on day by day you're inserting data. After few days, your data becomes very huge. In order to get some value, it takes some time. In order to speed up the retrieval of the data, we use the indexes. So we create indexes on the table. Next constant is primary key. This is uniquely identifies each record in a table. Uniquely identify each record in a table. Next we have a foreign key. Foreign key is it enforces the referential integrity for record in other tables. Suppose we have 5 tables and you want to have relation between them. Then using the primary key and foreign key relations, you can make it as a relational database. Now we'll see what is the primary key. A primary key constraint uniquely identifies each row in a table. So it must contain unique values and also has explicit normal constraint. So when you make a column as a primary key, you cannot have a null value. A table in SQL is strictly restricted to have only one and only primary key, which is comprised of singular multiple keys. There can be multiple columns with the same primary key, or a single column can be made a primary key. In this case, see the example here. I'm creating a table called student having 2 columns, ID and name. I'm making the ID as a primary key. That means now my primary key will not accept any null value, and also same primary key will not store two same values. So this is the example of only one column is a primary key. In the second case, what I am doing is that I am making two columns as a primary key. So the combination of ID and first name is a primary key. That means I cannot have ID and first name both as null, or I cannot have the combination of ID and the first name as null for same for two records. So this is the syntax for creating the database at the creation level. You can also do it as after creation of database by using the alter command. Here, suppose here I did not mention my table as primary key. I didn't mention the table as primary key. Later, after creating the table student, I made it as a primary key. I made it as a primary key. Similarly, the second case also here, same case here in the first step, I forgot to create this primary key or table creation level. After the table is created, I'm saying alter table name, constraint name, fk underscore student. I'm saying you make a primary key for two columns. Okay, for two columns. What is a unique constant? So, like primary key, we also have unique constant. A unique constant ensures that all the rows in a table in the column are different. This provides uniqueness. For the columns and helps identify each row uniquely. Unlike primary key, there can be multiple unique constants defined by table. There can be multiple constants, multiple unique constants. Suppose I say that my roll number should be unique. My mobile number should be unique. That means these two fields can be two different unique keys. But unlike the primary key, you can have multiple unique keys. So in this case, I'm making my name as a unique key here. Then making the ID as unique key. I cannot insert two different same IDs. Second case, I'm see here. I'm making the combination of ID and the student both as a unique keys. So this is the syntax to create after the table is created. This is the syntax to make after the table is created. Next, we are seeing the primary key, we are seeing foreign key. Now we will see what is, we have seen primary key, unique key. Now next is a foreign key. A foreign key comprises of singular collection of the fields in a table. That essentially refers to a primary key in other table. Foreign key constant ensures referential integrity in the relation between two tables. A table with the foreign key constant is labeled as a child table, and the table containing the candidate key is considered as a parent table. So two tables A and B are in relation. So in this case, A will have the primary key, and this primary key will be a foreign key in the second table. So in order to see the syntax, create table ID. See here, I'm making the foreign key. Foreign key name is library. It is referring to the library ID. Okay, this is the syntax. Now, what is a join? What is a type of join? So join is used to as a part of the normalization. We will divide our tables into multiple tables as a part of the normalization. So we'll break our data into multiple tables. So again, to get back the data back, so we have to use the joins. So in the joins we have left join, inner join, right join, full outer join. We also have Cartesian join. So total there are 5 joins here. Okay, the first you have two tables here, two tables A and B. So in the matching data between both the tables will be the inner join. The left join will take all the records from A plus matching records from B. Similarly, this opposite to left will be the right, and we have full outer join between A and B. The entire data from both the tables will be there. Apart from this, we also have one more join called as cross join or Cartesian join. Cross join or Cartesian join. Cross join or Cartesian. There is a necessary set of join. Okay. Types of join in SQL. First, inner join is both the matching data should be. This is widely used to join queries. Join queries A and B, where the common data from both the tables will be coming up. The left outer join is that all the records from the left and the matching records from the right will come. If there are no matches from the left, from the right, display as null. Displays a null. The right outer join is just opposite to the left join. All the records from the right and the matching records from the left, no matches from the left will display as nulls. A full outer join is returns all the records when there is a match in either left or right. That means left and right, any matches will be displayed here. Now, what is a self join? A self join is a case of regular join where a table is joined to itself based on some relation between the two columns. Self-join uses inner join or left join clause, and the table alias is used to assign different names to a table within the query. So self-join is joining the same table to itself. Self-join is a join joining the same table to itself. It is a left join or self join. In this case here, I have employee and employee. Both are same tables. Here I am using the column alias called A. Here the column alias B. Both are referring to the same table. Because I am joining the two same tables, it is a self join. That's why I am saying A dot emp supervisor is equal to A B dot employee ID. So joining the same table to itself is a self join. Okay. Now, what is a cross join? Cross join is nothing but a cross product between two tables. So, cross join can be defined as a Cartesian product of two tables included in join. The table after join contains the same number of rows in the cross product of the number of rows in the two tables. So, if a where clause is used, it becomes inner join. Suppose here, suppose I have here three records. So you have three records in A, three records in B. When I say A cross join B, I'm going to get 9 records. A cross join B, I'm going to get 9 records. So total, so cross join means each record of A will be matched to all the records of B. Similarly, each record of B will be linked with all the records of A. So it is nothing but a cross product between two tables, 3 rows, 3 into 3 is 9 rows. Total you will get 9 records in the title. You will get in the 9 records in the cross join thing. Okay. Now next we will see what is an index. An index, a database index, is a data structure that provides the quick lookup of the data in a column or columns in a table. It enhances the speed of the operations accessing data from a database table at the cost of additional writes and memory to maintain index data structure. So data index is like a pointer in the database. So immediately you can get the data back. So create index name on table name and the table name and the columns values columns. Similarly, we have drop index. Drop is to remove the drop indexes, and we have a couple of indexes, types of indexes. The first is the unique and not unique indexes. The unique indexes are indexes that maintains the data integrity by ensuring that no two rows of a table will have identical key values. Once a unique index has been created as a defined in a table, uniqueness is enforced whenever keys are added or changed within the index. Then we also have create unique index. We have create unique index on roll number. When you create this unique index on roll number, you cannot have a duplicate roll number. Non-unique indexes, on the other hand, are not used to infer any constraints, but they are associated with non-unique are used to improve the improve the query performance by maintaining a sorted order of the data that used frequently. Now, clustered and non-clustered. Clustered index are indexes whose order of the rows in a table correspond to the rows of the rows in the index. That's why only one clustered is there for a table. A multiple clustered index will be there for all the same table. The only difference between a cluster and non-cluster index is that database manager attempts to keep the data in the database the same order as the corresponding key in the cluster index. Clustering index can improve the performance of the most query operations because they provide a linear path to provide the data in the stored database table. Now we'll see the difference between the clustered and non-clustered table. As mentioned below, the difference between into three factors. Clustered index modifies the way records are stored in the database based on indexed column. Non-clustered index creates a separate entity within the table which references the original table. Clustered index is also used for easy and speedy retrieval of data from the database, whereas fetching data from the non-clustered is a little slower. In SQL, a table can have a single clustered index, whereas it can have multiple non-clustered index. Okay, so by default, when you create a primary key, a default clustered index is created. Next is what is a data integrity. A data integrity is the assurance of accuracy and consistency of data over the entire life cycle, and it is a critical aspect of the design, implementation, and usage of any system which stores, processes, and retrieves data. It also defines integrity constraints to enforce business rules on the data when it is entered into an application or a database. So data integrity is an assurance of accuracy and consistency of the data on the entire life cycle. What is a query? A query is like an SQL command used to fetch data from the database. A query is a request for data or information from a database table or a combination of tables. A database query can be either a select statement or an action query. In this case, see the first query: select name, first name, last name from my student DB, where student is equal to 1. That means I'm requesting the database to give me the name of the first name, last name of the student whose number is 1. Similarly, this is the select query. In the second case, I want to update the name of the student to Captain, last name is America, for the same student 1. So here, this is one select query, this is an action query. So that is an action. A query is a request of data or information. What is a subquery and the types? A subquery is a query in which another query known as the nested or inner query. It is used to restrict or enhance the data to be queried by the main query, thus restricting or enhancing the output of the main query respectively. For example, here we fetch the contact information for a student who has enrolled as a max subject. So here two queries. So this is the second inner query. This is the inner query. This is the outer query. This is outer query. So the output of this inner query, the output of the inner query will be passed to the main query. So here I want to know this. Here what I'm doing is that for max subject I'm getting the roll number, and for this roll number I want to know his name, his mobile and address. So subquery is is one or more query which is enclosed in the brackets. The output of the inner query is passed. The output is input to the outer query. The types of subqueries: correlated and non-correlated. A correlated subquery cannot be considered as an independent query, but it can refer a table column in itself. A correlated subquery cannot be considered as an independent query, but it can refer the column in a table listed in the from of the main query. A non-correlated subquery can be considered as a independent query, and the output of the subquery is substituted in the main query. What is in a select statement? A select statement, select operator is in SQL used to select data from the database. The data returned is stored in a result table called a result set. As a result set. So here my table name is student. I'm getting data from the select statement by select star from student DB. Now here my data will be retrieved from the student DB. So student DB could have few rows. You could also have few rows and few columns. Few rows and few columns. So select statement is use a command to get data from the database. What are the some common clauses used in the select query? So most the part of the select query could be a where clause and order the clause. So where clause is used to filter the condition based on conditions. So we don't want to enter data, you want only specific data. Then we use the where clause. In the order by clause, is to sort the data based on ascending or descending. By default, it is ascending, means the default is ascending. And also we have one more descending. When you say ascending, it is A to Z or 1 to 10. 1 to means lowest to highest to A to Z. When you say the descending, it is Z to A and highest to lowest. This is the select and order by clause. A group by clause is used in SQL to group records with identical data and can be used in conjunction with some aggregate functions to produce summarized results from the database. So group by is based on a group. You want to sort the data. You want to use aggregate functions. Same way, having clause is used to filter the group conditions. So here, for example, here I want to count of students country for each country. A country is not India. Group by country having a count of student ID. See this when I execute this line, I'm going to get all the student count from various countries. The country is not India. After getting that, I want to filter the data. Here I am saying I want to only the count of students who are greater than 5. I don't want to countries where the students are less than 5. So group by and having both comes together. Having clause will occur only with the group by, and having clause cannot exist with the group by. Group by can exist without having clause, but not the vice versa. Okay, what are the union, minus, and intersect commands. The union operator combines and results the result sets retrieved by two or more select statements. So union command is used to combine two or more result sets. The minus operator in SQL is used to remove duplicates from the result set obtained by the second select query from the result set obtained by the first result set, and then returns the filtered from the result set. So minus operator is used to remove duplicates from the result set obtained by the second result set from the obtained from the first result set, and it returns the filtered result sets. Intersect clause in SQL combines the result set fetched by the two select statement where records from one matches to other and returns interaction of the result sets. So certain condition needs to be met before deciding or executing either of the following statement in SQL. Each select statement within the clause must have same number of columns. So in order to use this command, you must have the same number of columns. The column should have the similar data types. Also, the same column should also be in the same order. So 3 conditions to be matched here. To be matched here, same number of columns, same number of columns, same data types, same column order. We here select name from student, union select name here. Here you will not. Here we will get the we are combining two. We are combining here two result sets. Student result set, column result set. Same way here also we'll get the even the duplicates also will be coming here. Here you will not get the duplicates. Here we will not get the duplicates. Okay. Similarly, select name from students minus select name from contacts. Then when you execute this command, you're going to get fetches name from the students, that are not present in the contacts. So you get those students who are not in the contacts. When you intersect, when you use the intersect, you're going to fetch names from students that are present in contact as well. Okay, now we'll see what is a cursor and how to use a cursor. A database cursor is a control structure that allows us for transversal of records in the database. Cursor like to read each and every row sequentially. Suppose when you say select star from table, all your data will come getting at the same go. But you want the data to be processed each record by one record. So in addition, facilitate processing of transversal retrieval, addition and deletion of database records. They can be viewed as a pointer to one row in a set of rows. So cursor is like a temporary table which holds all the data, and you will be processing each row by each row. So in order to work on it, in order to work on a cursor, you need to follow the it commands. It's out of the command. First, we have to declare the cursor. And we have to declare a cursor after any declaration. The cursor declaration must be associated with a select statement. Then open the cursor to initialize the result set. Open the cursor. Then open statement will be called before fetching rows from the result. Then you fetch the records from the database and you go to the next record. Then after processing is over, you close the cursor statement and you remove them from memory. That is deallocate statement. Deallocate statement is going to remove the data from the cursor from the memory. So now that is no longer valid now. Now here I am declaring a cursor, declare name, @name as a cursor. This is a sorry. I'm declaring the cursor. Then I'm assigning the cursor to get data from this statement. Then I'm opening the cursor. I'm getting the fetch nest from the cursor. Fetch nest into name. Now I'll process the name. After my work is over, I'll close this cursor. I will deallocate this cursor. Okay. What are entities and relations? An entity can be a real world object, either tangible or intangible, that can be easily be identifiable. For example, in a college database, students, professors, workers, departments, and projects can be referred as entities. Each entity has some associated properties that provides it an identity. That is, an entity is like a real world object that is tangible or intangible. Okay, what is a relation? A relation or links between the entities that have something to do with each other. For example, an employee in a company can measure with the salary in the same table. So entities are: professor is entity, Max is entity, physics entity. Now professor belongs to Max is a relation. Similarly, process belongs to physics. These all are the relation entities are this. List the types of relation in SQL. We have one-to-one relation, we have one-to-many and many-to-one, many-to-many, and self-referencing relations. One-to-one is that this can be defined as relations between two tables where each record in a table is associated with the maximum of one record from other table. Each record in one table is equal to only one record in other table. That is one-to-one relation. One-to-many and many-to-one. This is the most commonly used relationship where a record in a table is associated with multiple records in other tables. Multiple rows in other tables. And we have many-to-many. This is used in cases where multiple instance on both sides are needed for defining a relation. This is used in cases where multiple instances on both sides are defined for a relation. And last is self-referencing relations. This can be used when a table needs to define a relation between itself. When you use a table like self-join, what is a self-join? Joining the same table itself is a self-join. That is a self-join. What is an alias? An alias is a feature of SQL that is supported by most, if not all, DBMS. It is a temporary name assigned to the table or table column for the purpose of particular SQL query. In addition, the aliasing can be employed as abstraction techniques to secure the real names of the database fields. A table alias is used in correlation name. A table name is used as a correlation name. An alias is represented explicitly by as keyword. In some cases, same can be performed without as well. Notice as is a good practice. So here, select a.employee name as employee. Here, I am making a column alias employee name, emp underscore name as employee. Now this is my column alias. Same way, employee.b as supervisor. Employee A and B. Now here, these are the column aliases. Supervisor, employee is a column alias. Supervisor, column alias. Similarly, for table, I used A and B. Here, A is a table alias. B is also table alias. So A dot, this is the join condition. So in alias we have two types. Table alias and column alias. Column alias. When you give a alias for the column, it's called a column alias. Like for example, student S name as student name. Then it is column alias. Here the student S name is a column name. Similarly, for table, if you have table name is student table, I make it as student master. This is my table alias. This is my table alias. What is an alias? An alias is a feature of SQL that is supported by most, if not all, DBMS. It is a temporary name assigned to the table or table column for the purpose of particular SQL query. In addition, the aliasing can be employed as abstraction techniques to secure the real names of the database fields. A table alias is used in correlation name. A table name is used as a correlation name. An alias is represented explicitly by as keyword. In some cases, same can be performed without as well. Notice as is a good practice. So here, select a.employee name as employee. Here, I am making a column alias employee name, emp underscore name as employee. Now this is my column alias. Same way, employee.b as supervisor. Employee A and B. Now here, these are the column aliases. Supervisor, employee is a column alias. Supervisor, column alias. Similarly, for table, I used A and B. Here, A is a table alias. B is also table alias. So A dot, this is the join condition. So in alias we have two types. Table alias and column alias. when you give a alias for the column, it's called a column alias. Like for example, student s name as student name, then it is column alias. Here the student s name is a column name. Similarly, for table, if you have table name is student table, I make it as student master. This is my table alias. This is my table alias. This is my table alias. Thank you. With this completes the interview questions part one. We'll continue with the next sessions.